In Activity 9, Voltage in a Series Circuit, there are 3 resistors connected in series to a power supply that's outputting 10 voltages. For this lab, we have to measure the voltage drop across each resistor. What we found out was that each resistor had a lower voltage as you kept going along the circuit, and each voltage was varying in the series circuit. Next, we used the color code to find the value of each resistor and calculated the total resistance by adding all the numbers all together. Then we used Ohm's law to find the current by multiplying the resistance and the current to find the voltage. Then we used Ohm's law to find the current by putting voltage over the resistance for each resistor. And we concluded that in a series circuit, the current is constant across each unit.
When looking to determine the resistance of a resistor, you must first look at the first band to give the first digit. Then look at the second band and it will give you the second digit. The third band tells you the number of zeros there are, and the fourth band gives the tolerance, also the percentage that there might be error. For example, if it goes blue, gray, red, gold, blue equals 6, gray equals 8, and then the zeros from red mean that there are 2. And then, because it's gold is the last one, it would be 5% error.
In Activity 10, there are 3 resistors connected in a parallel circuit, and they are attached to a power supply where the voltage is 10 volts. And for this activity, we measured the voltage drop across the resistors. We measured the resistance, we measured the voltage for each resistor, and we found that it was constant throughout the whole experiment. And we used the color codes to find the value of each resistor, and we used the equation 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. And then we used the lovely Ohm's law to find the current within the circuit, and we found that the current through each resistor varied, but the voltage stayed the same.
A circuit diagram is a graphical representation of an electrical circuit. It shows all the connections and components within one circuit. To do this, there are many symbols that represent common components within a circuit, such as resistors, power sources, and voltmeters, ammeters, etc. This is an example of a series circuit. In a series circuit, there is only one path for electrons to flow. And this is a parallel circuit. In a parallel circuit, the main path branches off into multiple paths for the electrons to flow. Because of these branching points, in a parallel circuit, the voltage is always the same. Think of circuits as water pipes in your house plumbing, where water represents the sea of electrons flowing between taps. Water pressure is the voltage, and the flow rate of water is the current. Because there is only one pipeline in a series circuit, the water pressure drops every time a tap is turned on and water is taken away. But the speed of water flow is always constant. In a parallel circuit, the water pressure is unchanged before splitting off into its branching pipes. giving all the taps the same water pressure. But with the branching and different components within each pipeline, the currents can vary.